So we just started it.
No, we did completed the chapter. The exercise.
Sure. Okay. So we did everything. Anybody else's note? What about weather forecasting or did we?
Yes, it is, sir.
We did all that?
Yes.
Okay, very good. So we'll do that. Let's do the numerical then. Anybody has the volume? Is anybody online also?
So,
Pressure in fluids numericals. Very good. Okay, so the first numerical is I'm doing classwork numerical from YouTube. This is page number 62. So what is given is, I think it is also your book's first numerical, okay? So it says the hammer exerts a force of 1.5 Newton on each of the two nails, right? So this is question 1. So force on nail A is given as 1.5 Newton. An area of cross section of tip of nail A is how much? 2 millimeters square. Okay, calculate the pressure on each nail. So what is the pressure on nail A? It must be force upon area, right? So I've just given a suffix A for the nail name, right? Happy upon? Yes. So this is 1.5 divided by, so 2 millimeters square, how much it will be in meter square? 2 into 10 raised to minus 3, right? Whole square. Isn't it? That will be meter square. How much is 1 millimeter in 1 meter? 10 raised to minus 3 meter, right? So 10 raised to minus 3 square will result into this and meter square. Okay? Hope you're familiar since what is 1 millimeter? 1,000th of a meter, right? So this is 10 raised to minus 3, 1 millimeter. So this will be 2 into 10 raised to minus 6 meters square. This is Newton. So now how much this would be? So this would be 0.75 to 10 raised to 6 or fast. This is all. Right? Now for the second nail, nail B, again, the thrust on nail B is same, 1.5 Newton. And area of nail B is 6 millimeters square. Okay. So 6 millimeters square is 6 into 10 raised to minus 6 meters square. So to convert the area. Area of pin or nail beam. So therefore, what is the pressure on beam? Thrust on beam. Yes. Come. What happened? You didn't make it the last class? No, yeah. So we have just started with numericals of this chapter. Question first from UT volume. So which is also the first numerical from your textbook. So what is it? This will be 1.5. Okay. 16 into 10 raised to 6. So what it will be now? This will be, how much this would be? 0.62 are 12, 3. 6 5s are 30, right? Into 10 raised to 6. We take one decimal, so this will be 2.5 into 10 raised to 5 Pascal. And we were expecting this. So when the area increases, the pressure will decrease. Okay, so we should be. Everybody signed it? Have you signed it? Anybody has any doubts in this? Why is the camera shaking?
Yes.
Wind blow. Shall we switch that off? You want? Huh? Okay. When it's on is okay or off is okay?
Okay.
On is okay. There's nobody online. No?
No.
Two. The next is everybody has UT volume.
Yes.
If not, I think this is a common question from book. I'll just read the question. The area of base of a cylindrical vessel is 300 centimeters square. Yes, it's the fourth question. So the area of a cylindrical vessel like this. Right. So area is given as 300 centimeters square. Water given density. So water is filled in it up to a depth of 6 centimeters. Let's say water is filled here. This is 6 centimeters. Water. And its density is 1000. Okay, density is given as 1000 kg per meter cube. So I have written it as 10 raised to 3. So first you have to calculate the pressure, right? So what is the pressure and thrust of the water on the base? The pressure exerted only. So how will we go about it?
Height into density into beam.
And we have to take G is equal to
Height into density into
10 meter per second square. That's given. G is given. Okay. It's the question, right?
6 into 1000 into 10.
Yes. the first part, E is equal to H rho G. So H is 6 centimeters, so 6 into 10 raised to minus 2. So we convert everything in SI, okay? Density is 10 raised to 3. Yes. Density is 10 raised to 3, and you have GS 10 meter per second. So everything is in SI now. Okay. So I will write over here. So this is 6 into 10 raised to minus 2 meter. This the area will be 300 into 10 raised to minus 4 meters. Centimeter to meter is, so 1 centimeter is 10 raised to minus 2. It is squared, so 10 raised to minus 2. So I've written everything in SI. So what is this now? So this is 6 into 10 raised to 2, which is 600 Pascal. Okay. 3 minus 2 is 1. 1 and 1, 2. Right. Next is going to find thrust. So what is thrust? Yes. So since pressure is equal to thrust upon area, so this gives us thrust. Thrust F is equal to E into T. Now T is 600. A is 300 into 10 raised to minus 4. So 10 raised to minus 4 and these 4 zeros will be gone. So this is only 18. 18. Thrust is 10. So I think these questions were simple. Shall I go to the next question? Question 3 is pressure on water. Pressure of water on the ground floor is 40,000 Pascal. Just see this question from the book.
The sixth question.
Yeah. So those who have textbook, it is the sixth question, right? UT volume, this is question number 3. So I am calling pressure on the ground as P1. P1 is equal to 40,000 Pascal. Okay, I'll have to call it PG, P ground. And P on the first floor is P1 is equal to 10,000 Pascal. Find the height of the first floor, right? So how will you find?
Pressure upon
Then you have density is equal to what is?
1000 kg.
So density of water is equal to 1000. So it's only water, so I will. It's equal to 1000 kg per meter. What else? G is equal to 10 meter per second. So how will you do it?
Pressure upon.
So have you understood what is the scenario? So let's say this is how the pipe is. This is the first floor and this is the ground. Right. So, what is the height here? Let's say this is the water tank. From here, this water is coming, right? The water. You take the height from here. So this is the height for ground floor. This is the height for first floor. Okay. So what is PG? PG will be HG, rho, and acceleration due to gravity. Height for the ground. Here, if you look at the height, it is P2 is equal to H1 rho G. Okay. So, what is the height then? Height is Hg minus H1. What do you have to find? You have to find this height. This height. Correct? So to find what is the height of the first floor, sorry, this is P1. Pressure at the first floor is this. Pressure at ground floor is this. But we have to find the height. So what is this height? It is full height Hg minus H1. This is depth actually. So depth for the ground floor is more than the depth for the first floor. So the difference in the depth is the height of the first floor. Is this logic clear? So now let's take the difference. So which pressure is more? So therefore Pg minus P1 is equal to Hg rho g minus H1 rho g. Correct? So this is equal to Hg minus H1 rho g, or Hg minus H1 is equal to Pg minus P1 upon 2. Right? But Hg minus H1 is the height, therefore height of first floor. Is equal to, what is rho g? 44. One is 10. It is 1000 into 10. So 40 minus 10,000 is 30,000 divided by 10,000. So this is 3 meters. So you have to decode the logic from the given data. Right? How?
So first I got HG and H1.
Acha, you did it. Okay. Okay. Yeah, that you can also do that. Ultimately, what we are finding is Hg minus H1. That is all. Yeah. Everybody got it? What she did? So like instead of formulating this
That's
formula,
a long process.
actually it is the same thing, but you are doing the calculation earlier and
Yes,
later.
it's a lot of that.
It's long because I'm teaching. If I do, it will be very fast. I'm telling you to do na, ye karna, that's why it is. You and I have not done anything different. Is that right? What you found is Hg minus H1. That's it. It's looking big, not big. you don't have to draw this diagram. This is just to explain. Right? So has everyone understood alternate solution? Let's see. This is PG is equal to Hg rho G, right? And E1 is equal to H1, right? So 40,000 is equal to Hg upon 10,000, right? This is what she did. And this will be 10,000 divided by 10,000.
10,000.
This is H1. So this is 4, this is 1. H right? Four minus. So do either. As a teacher, I will follow the long route so that everybody understand what we have done. This is like shortcut. Both are there. So which one everybody will choose? The second one, if it is exam, right? But when you're understanding, so it depends. In exam, go with this. So it will save you a lot of time. Okay. Good. So everybody please contribute like this. Huh? So anybody has any other solution to this? So who is next one? At sea level, the atmospheric pressure is 1.04. Which question is that? This might be from exercise B, right? The exercise B.
Yes, third question. 102.
So it's 4 by 3.
Achha, sorry. Sports.
4 one, yeah. So how are we going? So this is straightforward. 4. What do we have? So given at sea level, PO is 1.04 into 10 raised to 5 Pascal. G is equal to 10 meter per second square. And density of air to be, and density of air is equal to rho is equal to 1.3 kg per meter. Find the height of the atmosphere. So H is equal to. So again, so E naught will be equal to H rho G. This will give height is equal to rho naught upon. So I have a habit of writing the formula till the last form, then substitute in that, right? So you can straight away substitute here and tell me whatever. So therefore, what is H? This is 1.04. Sorry.
8,000.
Let's check. So this is 1.3 into is 10. Here you have to take this 10 away. So this will be 0.104.
104.
So I'll finish the decimals. 104 into 10 raised to 3 divided by 13. So 13 8 times 104. So this will be 8,000 meter. Again, compared to 4A. Next question is, areas of pistons in hydraulic machines are 5 centimeters square and 625 centimeters square, right? So we have, so everybody remembers what is a hydraulic machine? So, question number 5. So hydraulic machine is a cylinder piston arrangement where you have one cylinder is small, is of small cross sectional area, and the other one is of bigger cross sectional area, right? So this is how it is. So the load is kept here, right? And the pressure is applied here, P1. And the same pressure, let's say here the pressure applied is P2. So we got P1 is equal to P2 by Pascal's law, right? So this is the part of theory. You don't have to do all this. Just because I am doing this example, so P1 will be what? F1 by A1. And this will be F2 by A2. So what do you have to find out? You have to find out what force on the smaller piston will support. So smaller piston force is F1 and this is A1. So this will apply force F2 on the upper piston and the area is A. Right? You have to find force on the smaller piston, which is A1 by A2 to F2. Now substitute. The area given in this question is, so on the smaller one you have 5 centimeters square, yes. 5 centimeters square, and then you have 621. Right? Now here, since it is the ratio, you need not change the unit because after changing also the unit is going to get cancelled, right? So you need not change the unit. And F2 is 1250. Right? So how much is this? So 25, 50 times. This is 25 times. Right? 5. So you're getting 10, right? So this is the answer. So the second part is state any assumption which you make in your calculation. So the assumption is like whatever pressure we applied, okay, everything got transferred. When is it possible? When there is no friction, so there is no energy lost in friction, right? And there is no leakage. Okay, because if there is any leakage, then the full pressure will not reach it. So this is a confined liquid. Remember, Pascal's law is applicable only for a confined liquid. So if there is any leakage, then liquid is not confined. It will flow out. Right? So the assumption in this case is no friction and no leakage. Okay, these are the two. Right. No leakage of liquid, you can see. Is everybody with me clear? Okay, let's discuss question 6 now. You've written this. So force of 50 kg force is applied to smaller piston of a hydraulic machine, neglecting friction. Find the force exerted on large piston. The diameters of the piston being 5 centimeter and 35. How would we do it? 6. So what is given here? Given F1 is equal to 50 kg. F2 we have to find out. F2 is equal to 1. Then A1 is equal to, so it is pi R1 square, right? Which is equal to pi D1 upon 2 wholes. Okay, and D1 is given to, D1 is equal to how much? 5 centimeters. Obviously, so it is cylinder now. Cylinders are circular. Piston. Huh?
We'll have to take the area of the cylinder.
Obviously.
Then we'll take the area of cylinder.
So what is the area of cylinder? Cross section of cylinder. No, see, the cylinder is like this. So what is the piston shape? Piston shape is like this. No? It is a circular disc, isn't it? So there is a shaft connected to it. So when you press it, how is the injection syringe? When you press the plunger, so what presses the liquid? The disc, right? So what is the cross-sectional area? Area is a cross-section of this.
Okay, and I thought they were talking about the area of the cylinder of the hydraulic machine.
No. So thrust upon area, it's always cross-sectional area. No? See, it's where is the thrust acting on this area? So this is circle. Okay. Everybody understood? I think she got. Acha, you thought the whole area of the cylinder, surface area.
Yes.
No. It is always the cross-sectional area. Like thrust is normal to the surface, right? That way. So this is full D1 or D2, whatever. This is the diameter, right? So radius is D1 by 2. D1 by 2. Right? Got it? So that's why we have taken this. And what is D1? 5 centimeter. The other one is 25 centimeter. D2 is 25. Okay, so solution. For hydraulic machine, F1 by A1 is equal to F2 by A2, right? Same logic, P1 equal to P2. So we have to find F2, therefore F2 is equal to A2 upon A1 times F1. What do we do now? And what was A2? Similarly, A2 will be equal to pi A2 upon 2 whole square. So take the ratio. Now, whenever the two quantities ratio is being taken, okay. So you need not convert it into SI unit because the units are cancelled. Okay. So you can use the same value. So what is A2 now? A2 is pi E2. A2 is in the numerator. U2 by 2 square divided by pi D1 by 2 whole square into F1. Okay. So pi cancelled, and this 2 square 4 will also be cancelled. So what you will be left with is D2 by D1 whole square. Now see, these steps are looking lengthy to you, but then you will understand, right, what we have done. So because I'm explaining, that's why. So what is D2 now? 25 upon 5. So I put the value in the end, and F1 is 50 kg. So this is 25 into 50. 25 into 50. 125. So it's 1250 kg. Is it correct? So why we had to do all this? Because area is not given directly. Area, instead of area, they have given you the diameter of the piston. Ultimately, we need area. So since it is of circular shape, this cross section of the piston, so to find area from the given data. Okay, everybody has understood why we did what we did. Okay, so in some question there could be radius given directly, so then you will use pi r also. In some question there, like previous question, we got area directly, right? Millimeter square, centimeter square, we were getting area directly. But here, area was given in terms of, area was not given, just what was given? Diameter. Okay? So diameter से radius निकाला, radius से area निकाला. And we did not do unit conversion because it's the same ratio. Both units are same, it's fine. Right? Okay. So 2 more questions to go from class 1. Then see these many questions will give you enough idea as to how to tackle question. Okay. There are other questions like homework in volume, then you have application type questions. Okay. So try that. Okay. Then there are some fill in the blanks type of questions. So keep trying, right? And if you have any difficulty, ask. All right. Most of it is covered in the theory. So let me take the next question. Which is, I will tell you. Yeah. So so for the next question, you need what is relative density. Okay? So for question 7, there is a concept of relative density. So it is nothing but, suppose I want you to find the relative density of copper. Okay. So relative density is the comparison of copper density with the water density. That's what it is. Okay. So any substance density is, so it is ratio of density of the substance upon density of water. Right? So in this question, what is given to you is relative density of mercury, right? So given RD of mercury is equal to, so this is density of Hg upon density of water. This ratio is given to you. How much is it given to you? 13.6. This is given to you in the question itself, right? Now, what do you have to find out? The mercury variometer records a pressure of 70 meter of Hg solution. given since P is equal to 0.7 meter of Hg. Okay, 0.7 meter of Hg. What would be the height of water column if mercury barometer is replaced by water? Right? So how much is this now? That is, so this is PHG. So P is same in both cases. And this must be equal to H water, rho water, and G. Right? So what is this? This is the height. So 0.7 is the height of mercury into density of mercury into G. Right? This is equal to height of water, rho water into G. So G cancelled. Therefore, height of water is equal to 0.7 into rho mercury upon rho water. And what is this given? This is 13.6. Right? This ratio itself is called relative density and it is given to you already. So how much is this? 7, 6, 42, 4, 7, 1 plus 4 is 1 plus 1, 5, 9.52. So at sea level, instead of mercury barometer, if you had to replace the mercury with water, right? The height of water would have been 9.52 meters instead of. Okay, so a water barometer will be very, very long or high, yeah, almost 10 times. This also we discussed during the theory. Now the last question. Yeah.
How is like
That's what is the question. See, at sea level, what is given in the question? At sea level. At sea level. The pressure measured in the mercury barometer is, so the level shown in the mercury barometer is how much? So this is shown as 70 centimeter. This is when it is mercury, right? But at this level, pressure is going to be this only. No? This level is not changing. Now, what is the question? Remove this water, replace instead of mercury, replace it with water. Now, water density is like 13.6 times less than mercury. What is mercury density? Rho Hg is 13.6 into 10 raised to 3. What is water density? Just 10 raised to 3. Okay. What is pressure? H rho G. Okay. So if we keep the density, so G is constant, right? So there is so pressure will be equal to product of height into density. Right? Pressure is same. This pressure is same if whether we use mercury or water. So since pressure is same, that means H into rho is equal to constant. Therefore, H1 rho 1 must be equal to H2 rho 2. So if we take mercury, height of mercury into height of mercury density, into mercury density must be equal to height of anything else into its density. That's what we have done. Height of mercury into density of mercury must be equal to height of water into water density. Because this product of height and density has to be constant. Since this is equal to pressure, same pressure. At this level, pressure is going to be same, right? So this has to be constant, the product of height and density. Okay, shall we proceed? Next. Here will be the last question. So again, it's a hydraulic machine based question, which is in a hydraulic machine, a force of 2 newtons. So for hydraulic machine, right, F1 upon A1 is equal to F2 upon A2. So this is a small piston, this is a bigger piston, right? Or by Pascal's law, since P1 is equal to P2, so we get this. So what are the different forces? F1 is equal to given. F1 is equal to 2 Newton, 2 Newton. And A1 is equal to 10 centimeters. So this is a straightforward question. Is equal to what? A2 is equal to 100 centimeters. So find out. Yes, exactly. So what is F2? F2 is equal to A2 by A1. No need to change the area units into Z1. So A2 is 100 by 10. F1 is this is your okay, we still have some time, so that will be covered. Application based question. Everybody has volume, no? Read question 5 in that. So question 5 says, when an air bubble rises from the bottom of the lake to the surface, its volume is doubled. Find the depth of the lake. 5. Application type. Right. So you have a lake. Let's say this is the height of the lake. So you had a water bubble at the bottom of the lake. Let us say its volume was B. Right. When it reaches the surface, 2V. 2V double. It is 2V. Right. So to find the height, what is the depth of the lake? So this is, let's say pressure over here is P1, right? And pressure over here is P2. Right? Now, what is the relation between pressure and volume? You have knowledge of gas law, Boyle's law.
P1 upon that
For
when the
constant,
temperature is constant.
E is inversely proportional to V.
Yes.
Okay. So V is inversely proportional to V. So therefore P1 is inversely proportional to V1 and P2 is inversely proportional to V2. Correct? Okay. Now atmospheric pressure will act till here. Right? So atmospheric pressure will act till here, right? So what is it now? So P2 is the atmospheric pressure itself,
Yes.
right?
Atmospheric pressure.
So this is P naught is equal to, so I can say P upon E1 by P2, E1 upon P2 is equal to P1 by P2, right? Yes. But what is V1 and what is V2? V1 is V is equal to 2 times V. Let's solve this. Okay. So P1 is equal to 2 times P2. Did I make it? 2 times P2.
So
And P2 is atmospheric pressure itself, right?
just
Yeah. Right. What is P2 then? So what is P1? P1 is equal to,
atmospheric pressure.
so P1 is equal to P naught plus H rho W G. This is the depth. What is P1? P1 is this atmospheric pressure plus the pressure due to water column. That is the pressure, total pressure at the depth. Correct? And this is equal to 2 times P naught. Because P2 is equal to P naught. Okay? P2 is the pressure at the top, right? So P2 is equal to P. So this is also, therefore, what is H? Therefore, H rho water G equal to 2 P naught minus P naught. Equal to P. And this is equal to 0.76. What is it? 0.76. 0.76 meter will be taken. Height into 13.6, that is the monthly thing, and raised to 3. Right? Into G. So G will be cancelled from both sides. And what is therefore H is equal to? And divide this. If this formula itself, I would have written it. 0.76. Divided by 10. Right? So find out how much is this. That is whatever comes will be the answer. So I think we are correct. It's about 10.6. The depth of the lake is roughly 10.3 meters. So only thing is there is an inverse relation between pressure and volume. That you have to apply it. That's a different application. In the next class, which topic you want me to start? Next chapter is upthrust in fluid. Yes. That is okay?
In our exam, we are having 4 chapters, 6 laws of motion, which fluid pressure fluids of course. Heat and energy.
Thrust also is there?
Yeah.
Okay, so next we'll be starting up first.
Heat and energy and friction.
Starting 3rd of September. So I don't think we'll be able to cover all those chapters because we'll be having 4 classes. So at most we'll be able to finish up thrust. The 2 chapters will not be finished. So what you can do is you can ask me questions if you have any doubts because I will be sequential. We have only 1 lecture per week, right? So I can take only 4 hours. And the hours allocated for chapter 5 itself is I think 5 hours. So if you have any special request, either you request for extra lecture, right? It is applicable to any of you. Same is the situation for everyone.
No.
There is also. Anybody else has any issue like that?
Sir, my exam is from September and I have to fill up.
Till first year anyway. Most of the schools have till up first. So for you it is exception. So you ask me if you have any doubt or request for an extra lecture because otherwise it will lead into their this time. Why is it request for extra? Whose volume? That is the next.
What is the the one who gives you